So example 3 and 4, again, one is going to be the first case, one's going to be the second case. So we've got our function here, y equals negative 3x, and we want to find the definite integral from negative 4 to negative 1. So I'm going to integrate from negative 4 to negative, again, be careful, negative 4 is the smaller, negative 1 is the bigger, negatives are always tricky. Now remember what negative 3 divided by x is. That's really negative 3 times 1 over x. And so when I take the antiderivative of this, the negative 3 is going to come along, and this is where it's very, very important that you remember the natural log is the antiderivative of 1 over x, and not only that, but the natural log, you have to remember absolute value, because the original function exists over negative values. And so when I find the antiderivative, because it's the natural log doesn't exist at negatives, to get around that, we take the absolute value of it. And if you don't remember that, you will get this one wrong, right? Because I am going to plug negative 4 in, and I'm going to plug negative 1 in. And if you try to plug them into the natural log without the absolute value, you'll get an error, right? Because we're going to plug them in. So negative 3 times the natural log of negative 1, absolute value. I said it, and then I forgot to put it. Minus, so actually plus, I'm going to change that to plus. Minus a negative 3 is really a plus 3. Times the natural log of the absolute value of negative 4. And so it's negative 3, natural log of positive 1, right? Absolute value of 1 is positive 1. 3 times the natural log of 4. And so the natural log of 1 is 0. And so this actually simplifies to 3 times the natural log of 4, which that's exactly what it's equal to. And then you find the approximate, which is about 4.16. Right, if we look at the graph, so again, that's what the integration from negative 4 to negative 1 of the negative 3 over x dx. The picture, right, when we graph the function given in the integral, negative 3 over x. And so this is the 1 over x reflected and stretched by 3. And so I'm not going to pop it in my calculator. I'm just going to go ahead and graph it because, again, this one's one of those functions you should know how to graph. But you can always pop it in your calculator. All right, so it's reflected, and so it's over here and down here, right? It's that sort of butterfly shape. And then the part we're looking at is negative 1 to negative 4. So negative 1 to negative 4 would be this piece. And so since the graph is completely right, this is all positive values here, that is actually the area of my function under the curve between 1 and 4. And so this is the area under f of x, or the function from negative 1 to negative 4, right, is equal to 3 times the natural log of 4 exactly, which is roughly about 4.6. All right, the last one of these examples, our function is a quadratic 2 minus x squared from negative 1 to 5. So again, we're integrating from negative 1 to 5 of our 2 minus x squared dx. So the general antiderivative is 2x minus x squared over 2, x cubed over 3 from negative 1 to 5. All right, and again, a lot of times we will get ugly fractions. It's just because of the way the antiderivative works, right? I always take my degree, add 1, and divide by that. And so we do get fractions a lot. We get a lot of 1/2 and 1/3 because of the nature of the problems. And so use your fraction key. Plug in 5, and you get this ugly number, and then hit your fraction key. It comes out negative 265 over 6. Minus, when I plug negative 1 in, again, it becomes an ugly number, but I hit my fraction key, and it's 13 over 6. Which is negative 265 over 6 minus 13 over 6. Comes out to be negative 42. Negative 42. All right, so it's exactly negative 42. All right, then we're going to graph the function and see what it looks like graphically. So remember, when we graph, which based on this picture, either all of the area or most of the area should be below the x-axis. All right, so remember, we always graph the original, not the derivative, so go back and graph the original function. Excuse me. All right, so I'm going to pop up my graphing calculator. Maybe if it... All right, so apparently my graphing calculator is frozen, so I'm just going to freehand graph it. It's a parabola that opens down. It has this shape to it. -1 is about right here. And then +5 is somewhere around here. And so this would be there is some positive area, but the vast majority of it actually, again, if you graphed it, would be off your graph. It would be way down. This would kind of go down here for a long time. And so there is some positive area, but most of it's negative. And when you take the positive area, subtract the negative area, this difference in area comes out -42. Right? So that means there's 42 more units of area below. Alright, that's what that means, right? If I take the positive area minus the negative area and I get 42 units of negative area, that means there's 42 more units of negative area than there was positive area. Alright, and that's sort of what the integral means. Alright, we'll stop there. We're going to, again, do some more, and we'll still graph it because I think it's important that you get a visual of this because it's going to play into what we do in the second section. Alright, we'll stop there. Pick it up in the next